In this video we're going to wire the 555 timer in bistable mode. The output's going to change depending on which switch we push last. And as always with the 555 timer we need to power it. So we got pin number 1 here to the ground pin, the negative side of the power supply, and then pin number 8, the VCC pin, to the positive side of the power supply. We're going to use 5 volts in this video. The only thing we have to add to the right side of the integrated circuit for this circuit is this jumper to ground that's going to pin 6, the threshold pin. That's waiting for 2/3 or more of the supply voltage by going directly to ground at 0 volts, the lowest voltage on the board. The pins that switch the output are the trigger pin, pin number 2 down here, second pin down. I got that going up to a push button switch. When I press the switch, it will connect directly to ground. Also pin number 4, the reset pin, same thing. We got to the switch there, we press the switch, we go to ground. They are active low, they're waiting for a low input to do something. We don't want these inputs to do something early, so to make sure they stay off until we press the switch, we use a pull-up resistor. So 10 kilo ohms should work well. That keeps 5 volts until we press the button. Then we have a direct connection to ground for 0 volts. So we got one right there, and we got another one for the switch that goes to the trigger. We could also put it closer to the inputs, but then it'll be a little more cluttered. So now that was it for the actual flip-flop circuitry. We have the output, and to do something interesting, we're going to take a 1000 ohm resistor, 1 kilo ohm resistor, and an LED here. So this side is the more positive side, the power supply. So we're going to put the longer lead right there, and shorter lead, the cathode, we're going to the resistor. Longer lead, the anode. Then the LED will light up when the output is low. And of course, to make it more interesting, we'll add another LED that lights at a different time. So we have a 220 ohm resistor to the output right there. It's one space away from this gray jumper that goes to the negative side of the power supply. I'm going to take a red LED. The longer lead, the anode, I'm going to the resistor. Shorter lead, the cathode, going to ground. I have a lower value resistor for the red LED because it doesn't get as bright. And so this should even out their brightnesses. So the red LED is going to light up when the output is high. You can see that goes to ground. And then when the output is low, when it's connected as close to ground as it can get, then the blue LED will light up because we got that path there and then going to ground. And now we'll turn the power on, and we can see the output is low. That's how we wired this. So what sets the output high is the trigger pin right there if we give it a low signal. And now it's going to stay high until we press the reset right there. So that's why it's called a flip-flop. It doesn't move until you push the button. It's also called bistable because that LED is going to stay on until I hit the button. That one's going to stay on until I hit the reset button. So trigger button, reset button, set, reset, whatever you want to call it. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. Click like, subscribe, the bell, all that. Donate to Patreon if you can. That helps out the most. But simply watching videos helps a ton. Thanks for that. I'll see you in the next video.